Polymerase chain reaction, or PCR, is one of the most important and widely used methods in synthetic biology. PCR is used to amplify DNA, where you start with a particular DNA sequence, and by running the PCR reaction, you can generate thousands or even millions of copies, depending only on how many times you do the reaction. To run this reaction, you need to have a couple things besides the DNA you want to replicate. You're going to need primers, DNA polymerase, deoxyribonucleotides, or DNTPs, the appropriate buffer, and water. Now, the way that PCR works is as follows. The DNA is heated so that the two strands separate or melt. Next, the primers, which are partially complementary to the desired sequence, attach to the DNA and begin replication. After the primers have attached, the DNA polymerase starts adding complementary bases to each strand of DNA until each single strand has become a fully replicated double strand of DNA. Each cycle of PCR doubles the amount of DNA you previously had, which can be shown mathematically by the expression 2 to the n, where n represents the number of reaction cycles run. 10 cycles would be 2 to the n strands, or 2 to the 10 strands, meaning that after only 10 runs, you can have up to 1,024 copies of DNA, assuming you had started with a single strand. A typical PCR reaction will run for about 30 cycles, but this amount can be customized by programming the thermal cycler.